Hey, everybody, welcome to the Alomar Designs podcast show. This week, we're going to actually do something a little different. Um, got me thinking. The other day, Dave and I finished shooting Coffee with Al and Dave for actually next week's show. And it got me kind of thinking about the kind of products that we were discussing in the show. And one of the products is brand new well, it's not brand new for me because I've been known to build these over the years or design them for other companies. But we're getting ready to come out with our new what is called an EVO or an evolution power cable, and I wanted to kind of discuss that with you because a lot of people don't really realize they think that EVO, but let's see how that goes. Oh, come on, come on, come on, come on, come on. It's we just got a freak storm outside. Oh, 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 come on. Redo. Okay. Anyway, so what was I saying? Oh yeah, I remember. So a lot of people really think that these products are basically they're designed for other uses, not realizing that I am just a power designer. I don't build things for stereo systems or for the EMF world. I just build power based products, and they're both sides. And I say this thousands and thousands of times that both sides can use the products. They're designed to be used together. It's just there's a mindset that kind of prevents it from really taking place. Don't get me wrong, I have some audiophiles that will trust me and they'll put a pocket ground or they'll do this or they'll do that. But, or they'll get a quad wave or whatnot. But I never really get from the EMF side where they say, well, sure, we're gonna plug that in because that's for the stereo system. They're kind of like snobs. They kind of like look down on the product line, which is a shame. And let me just kind of like explain the EVO power cable, right? It's not cheap, so it's something that um, is an investment. Shut the hell up! Fucking rainstorm, out of fluke rainstorm. Anyway, so first and foremost, what would an EMF style of individual use the EVO power cable for? Well, let's take a look at your home. Okay. Do you own a laptop? Do you own a computer in an office, in a home office? Do you own a printer? Um, okay. Three different ideas. Does your significant other or yourself have a television set, or do you have a minor, small little home theater that's a receiver based and this and that, but everything's plugged into a power strip? That type of stuff. The idea behind the power cord is that it filters incoming, but it also filters outgoing. So it's a bi-directional design. Now, I'll give you just an example. Let's say that you have a computer in an office, right? And it's just a standard mid or full tower computer. You have a detachable power cord on the back of the unit. You take that cord and you replace it with the EVO power cable. Now, the power cable, just like I said in yesterday's video, I said it's designed to be plugged right into the wall, no power conditioning required, right? So you plug it into your PC, you plug it into the wall. Okay. Now, within 15, 20 minutes, you start to notice that it's already filtering. It does a few different things. Think about the way a computer generates noise, right? Internally, a computer is one gigantic EMI factory, right? All these different components in close proximity to each other, just ramping up EMI. Now, EMI from a computer leaks a couple different ways. One is through radiation, so it leaks out from the cabinet. And in other cases, it leaks through the power supply, through the cord, back to the wall. And then that goes and amplifies, okay, interference that's on your line, which now causes everything else on the circuit or within the electrical panel to react to it. So, what if you could go ahead and spend money on a cable that you plugged into the unit that did a few different things for you? First thing is that it lowers noise going into it, so you have less interaction inside the unit. Number two, it allows your computer to run cooler because now you don't have any real EMI interference going on the inside. So you have less magnetics that's ramping up the thermal temperature. Number three, now you have less leaking back to the wall. So everything else that you have plugged in on that circuit, maybe your printer, maybe your monitor, maybe your little Bose radio that's off into the corner, maybe one of the lamps. None of that stuff is now actually producing extra thermal temperature because it's interacting with the EMI on the line. The radiation that was being leaked from the cabinet, from the computer case, is now much, much lower, if at all. A lot of times you can actually completely erase it. If you can lower the thermal temperature on the inside, which is really what radiation is all about, then you can lower what it's actually producing. Give you another example. Let's say that you're looking at a basic home theater, right? You have a TV, you have some form of a video source. Maybe it's a streamer, maybe it's a Blu-ray player. Then you have where all these now come into a hub, right? The hub is a receiver base of some sort, okay? And then from the receiver base, you have a set of speakers. Okay, now we don't care about the speakers, but maybe we do. I'll explain that in just a second. So now what we're looking to do is we want to go and lower noise. Now, different components respond differently. Digital components like your Apple TV box, your Roku box, your streamers, or your player base use what basically as miniature switch mode power supplies. Now, these types of power supplies dump a tremendous amount of high frequency or electromagnetic interference EMI back onto the line. If you get higher levels of EMI, then within the electrical circuit itself, that ebb and flow of electricity, remember what we always teach is that electricity doesn't do this. It doesn't move from here to here. It does this. It pulsates. So as you increase the EMI level into the pulse, your pulsation level actually grows. Now, that's not to say that it's going to stay that way. No, because what happens is now it does this, right? It collapses. Well, a collapse is what is considered a burst. So as it bursts into your room to compensate for that flow, you now dump the room with higher levels of EMR, electromagnetic radiation. Okay. So what if you could swap the cord out on the player? Interesting idea, neat concept. Not all of them do it. Some have hardwired plugs. Nothing you can do about that. Maybe you have a strip where it has a detachable power cord. Maybe you can start there. Boom, you pop that on. Everything in the strip has slightly reduced, feel. Because depending on how many things you have plugged into the strip, you have to divide the effectiveness of a single product, right? So if the cable is able to give you 100% performance, yet I plug it into a strip, and the strip has got three different things plugged into it. I have a TV, I have a streamer, I have a receiver. Now, 100% is now kind of divided to 33 and a third for each connected appliance. That's why we give these cables their own dedicated. I plug it into the receiver. Okay, I plug it into the player, that type of deal. That way you get a 100% of the electromagnetic and RF coverage that the cable is able to provide. And not all cables are designed to do that. This one in particular is designed. It's heavily shielded, and it's also filtered to filter out electromagnetic interference. So it's a 2-for-1 type of design. I'll give you an example. Here's the specs of the design. Okay. The internal wiring, I'm using what is called 7/9 OCC copper. That's basically considered hospital grade metallurgy. What does that mean to you? That means there are 0 impurities inside the wiring. Now, the reason why we try to shoot for 0 impurities inside the wiring, because every time that you get a little nick in the cable, in the when the wire is created, right? Wire, as you know, just doesn't come out of the ground. They have to melt the copper down, and then they have to go and basically draw the line, right? It's you put it in that, and boom, 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 you create it out of a mold. So if it's not like really high quality copper, like a penny, for example, is what we call it as 4/9 copper. It means that it has bronze in it, it has copper in it, it has zinc in it. It's it's really only copper in appearance. Or you go and you buy a gold coin off the TV. It's gold in the sense that it's electroplated, but most times out of that, it's not high quality gold. Okay, it's got a lot of got a higher copper content to it, and or a lot of times they're electroplated over top of silver. That's why I don't like the precious metals coin market, because they rob you. Okay, it's not the same as actually going to the treasury and buying a gold certificate versus a coin that you collect and you put it in a little thing at home. Um, so when we draw the copper out, it's the impurities have to do with how purified the metal is, how much the ratio of copper is it in the metal, number one. Okay. And number two, how many little artifacts are in the wire. So if you go and you buy something like, you go to Home Depot and you buy Romex off the spool, right? That's just the wire that goes into your walls. Romex is considered 4/9 copper. Now, anybody in the business will tell you that 4/9 copper is absolute crap. It's mostly bronze versus copper. Okay, so it doesn't hold its magnetic value as much as you would like it if you were dealing with copper, and that's because it doesn't hold its value. Your ebb and flows of the wire are actually more extended outward. That's why you can measure magnetic fields from the wall 3 feet, 4 feet, 5 feet away, versus if it was a solid copper, where we're now looking at 6/9 copper, which is considered medical grade, entry level medical grade. And then you have 7/9, which is basically Japanese drawn out copper that has zero impurities. You'll notice that they have a much stronger, the wire itself has more magnetics to it. So instead of the flow being this high, it's really now only this high. So it's doing this instead of doing this. So you get less of a burst coming out of the wall. But nobody goes and makes in wall wiring as 7/9 copper, unless it's a specialty. I mean, you can go to places like Cardis Audio that will sell it to you for $150 a fucking foot, and if you're crazy enough to buy it, more power to you. But you're not going to get it. You're not going to go to Home Depot and buy OCC copper. You're just not going to do it. So you're stuck with either what's in the Romex or in the BX cable, and it's all the same shit. It's 4/9. It's just junk. So what we're trying to do here is that if we can go and create a cable that's OCC 7/9 copper, the wiring itself, when we're giving you from point A to point B, from the wall socket over to the inlet to the device, we're now expanding the flow much smaller. That's a good thing. And you say, well, why is that? Well, the larger that you do this, the greater the thermal temperature is of the application, meaning that inside that power supply, that's inside the computer, you have EM cores, okay, EM chokes that are in there to keep the DC line stable. They now run about 50% less heat than they would have if you just ran the basic power cord. Okay, when heat comes off, it's radiation. Now you have a whole bay of electrolytics on the inside. These are the capacitors. Okay, you want those capacitors to do their job, but you want them to do their job at 50% less energy that it would have taken for them to stabilize. And you say, well, why? Well, because in electricity we have active power and we have residual power, right? Residual is what we waste and we don't actually use, which is discharge to heat or whatnot. And then you have active is what we actually required, okay, to use. So when you do a cable like this, you lower the usage by 50%, literally. And the fact that I'm using 7 gauge guarantees you that you're using 50% less. Now, at the same time, now we get through the wiring and we now have lowered the thermal temperature just to supplying. Okay, you can I think you can understand from that moment that if we lowered the thermal temperature of the power supply, then you lowered the thermal temperature of the motherboard and of the hard drive and everything else that's connected inside. And if you didn't, that's what's happening. Now, here we go. Now we go ahead and we shield it. Nice thick layer of shielding. Okay, this is not foiled shielding. This is a really thick 105% 6/9 copper braid. Again, using that medical grade of impurities draw. Okay, you wind up getting a much more conductive, which is very important in a shield, a much more conductive a mechanism to reduce leakage. It's not that you're trying to reduce RF from coming out of the computer going out into air. You're trying to reduce RF that's in the air going into the cord, but at the same time, because this is a conductive design, it's an inductive design. Okay, you're trying to make sure that within the 6 foot of cable, excuse me, the 6 foot length of cable, that any RF that's coming in from the wall is now just squelched off inside of the inductive field that is self-generated by this big, huge, thick 6/9 copper shielding. So I guarantee, one of the things I said in the show the other day is that I really have the cable voiced to a 2 meter as the minimum. I mean, 3 meters is great, 4 meters is great, but anything less than 2 meters, you still get the performance, but you don't get the as low of a frequency reaction as far as lowering the noise for. And so, when you're designing cables, the shorter the cable, the more high frequency ringing that's involved in the length. So we always try to lengthen it because it does two things. It adds more weight to the wire that you're trying to vibrate. So obviously your vibrations start from this, at 1 meter, and then by you get to 2 meters, it's much more like this. And you want it slow as possible because the slower that you can get those vibrations, the better of a chance you have of inducing any high frequency noise, when it interacts with the shielding. So that's the whole concept of doing it. It's the same concept as a blocker, right? A lot of people ask me, why do I tap the case of a blocker and I feel a little vibration? And that's because the blocker is basically what is known as a floating circuit, right? It's a floating grounded circuit. So it's proper, it's properly weighted and so forth. And the whole idea is that when high frequency noise comes in, right? Let's just say it's Wi-Fi, just for the fuck of it. Okay, so you got 2.4 gigahertz. It comes in, it's attracted to the magnetic field, the grounded magnetic field of the blocker. It now hits the resonator, right? So instead of hitting the resonator doing this, okay, the resonator is stiff, it's weighted, and the resonator starts to do this instead. It slows the vibration down, which dramatically lowers the frequency of that vibration being grounded back at your wall. The whole idea is that when you are dealing with electricity, right, you have everyone has heard that we have even harmonics and we have odd harmonics. Odd harmonics is where all types of distortions are created, EMI and so forth. And so, if you are able to reduce the vibrational pitch, okay, by using something like a resonator that slows it down, okay, what happens is that you are now dumping back what is known as an even harmonic, which for the likes of Romex and BX cabling, the in-wall wiring, it is so much easier for that to be able to absorb the RF as an even multiple, okay, within the expansion, and then you don't ever have to worry about it. Whereas if you kind of throw it If you like for a boxing analogy, you're coming in, you boom, your body, the body, the body, the body. All of a sudden, you come back with this really real rare overhand right. Consider the overhand right as an odd harmonic. Well, every time you try to put an odd harmonic into this expansion, you create a ripple because the expansion is really based on what line frequency is. Now, here in North America, line frequency is technically 60 hertz, right? Even though you can put a scope on the line and it can be 58, 59, 61, 62, 60. And this is every single second. It's always changing. You say, well, why is it always fluctuating like that? Well, because you get reflection waves, okay, within your electrical line. So if you have something plugged into it, right, a coffee maker or a lamp or whatnot, okay, if these devices are plugged in, they don't got to be on. They just need to be plugged in. They'll give you a reflection wave, which kind of fucks around with the frequency just a hair. But the overall average of the frequency will still remain at 60. And that's another thing we're going to talk about in just a second. So the whole concept of plugging the computer in is that you do not want the computer to cause all these different offshoot ringings. So if you can squash and regulate that frequency, which you cannot do in a generic cable, okay, it has to be a thicker wire that's more than what the circuit requires. So if you have 12 gauge in the wall, you say, well, why would you put a 10 or an 8 or a 7 gauge cord on the appliance? And that's, again, you are trying to lower how that wire inside that cable vibrates. And the slower that you can do it, that just means you just have less EMI, less RF that's either leaking back to the wall, or if you shield the cable, that's being allowed to leak from the cable or being absorbed by the cable. So there's a lot of different things with it. Now let's take a look at the receiver. Right now, the receiver has got um, a lot of digital chips on the inside, right? So your husband wants to watch a movie and it's in Dolby Atmos. No, it's in DTS. No, it's in Dolby Digital. It's in whatever friggin' Hollywood multi-channel thing. So each one of those chips give off a ringing frequency in the circuit board and back at the wall, but at the same time, inside and exterior to the case. You can very easily take an RF meter and go and measure it. If you knew that as long as you're able to dial the meter into anywhere from about 1 gigahertz up to about 8 gigahertz, you will absolutely be able to find the frequency that chip is operating at, that chip's operating at. Okay, so and that's just the digital chips. Don't forget the MOSFETs, megahertz, frequency ranges, and this and that and everything else. So you can find several different electrical frequencies coming off of just the receiver. Whereas now you take a cord like mine, you plug it in, and what is the first thing that the cord does? Well, it's 7 gauge. It's a really big, thick wire. Now, hopefully, the receiver has the third pin, but it's a really thick, big wire. You say, okay, I don't comprehend. Well, generally, inside the piece of electronics, from the ground pin of the inlet, the power inlet, it goes and it just bonds to the metal of the case. They just screw it down to the case. And the whole idea is using a larger power cord like this is that you plug it in and it energizes the case. Now you may know the familiarity of a foyer cage, right? So if I am to go and I take a piece, an electronic that's a metal case, generally the case is supposed to act as shielding, but you have to make sure that your delivery system, your receiver, your bonded piece of wire is able to handle the frequency. Because understand, frequency in an electrical circuit doesn't flow through it, it flows around the surface of the wire. So if you have all these high frequency noises inside just the receiver, then you need to make sure that the wire that you are connecting to the ground in order to set up the Faraday cage is large enough to be able to support the drain of these high frequencies. Because if they don't, what happens is you just get reflection. That reflection creates ripple, and you just measure a much wider band of crap that comes off the unit through air. So you want to make sure that this component that was delivered to you with either a 16 or a 14 gauge, if you were lucky enough, power cord, okay, by giving it a 7 gauge cord, you are guaranteed that not only is the wiring large enough to handle all the frequency that you were trying to drain off the unit, but so is the inductive rate inside the cable between the interaction of the wire and the shielding, that by the time it from this end of the cable to that end that's plugged into the wall, you are completely noise free. You are not dumping anything back on the line. Now that doesn't mean that if it's a shitty design, and let's say it's a Chinese design, and they're using a bleed resistor to ground, which is causing hum. I can't stop hum, and neither can anybody else. It's part of the fucking design of the component. But if you're not dealing with that kind of stuff, then the whole idea of an upscale power cord is that you eliminate the noise from end to end. A lot of cables can't do that. They're voiced to give you a harmonic change, and you say, oh, fantastic, I hear the difference. But there is no measurable reduction of noise whatsoever. Just like there's a lot of power conditioners out there that there's no measurable noise reduction whatsoever. It's just designed to give you an experience. And audiophiles, they know damn well what I'm talking about. You pay for the experience. It doesn't mean you actually received anything realistic. You're paying for your perception of the experience. Um, you know, I went and I did. I sent Dave a video the other day. I was showing him the new cable, and I have a tube preamp in my theater, and if you know anything about electronics, you know that tubes are kind of they're prone to RF and stuff like that, airborne RF. Anything that causes the tube to vibrate will come through the circuit, and that's one of the reasons why we put low frequency isolation platforms under them. So anyway, long story short, now a I am an audiophile because I like music, not because I like electronics. I don't really like electronics. I really like music. It makes sense, the industry I used to work in, and so on this piece of gear in particular, it's kind of a, Tiffany style. It's really a glitzy brand, and they do a lot of tweaks to make things happen. But anyway, it's basically it's a power cord that for 5 feet cost me $5,500. You go, what? And then its shielding is DC biased. It's using shielding like I'm describing, but then they go and they put a DC bias charge onto the shielding. And depending on the direction, that we put the bias or the impedance, we're able to revoice the caliber of the overall performance of the cable. So if you want the cable to sound warmer, you change the bias to this. If you want it to sound a little brighter, a little bit more open, a little more airier, you change the bias to that type of deal. But anyway, on this particular preamp, I can tell you with the tubes that I have inside of it, it usually sounds good after flipping it up from a cold start. It generally sounds good about 3 hours. After 3 hours, everything is nice and warm, and it sounds nice. But I didn't do that this time. What I did was I did a cold start, and we did a really quick video recording of one song. And then I turned it off, let the tubes cool back down to room temperature, chopped out the power cord, put my power cord into it, which was plugged directly into the wall, and where the other one had to be put in a power conditioner, all this other stuff, and um, flipped it back on. As soon as the tubes warmed up, which took about 45 seconds, I pressed play and we recorded it again. Then I took a half hour, and then we pressed play just to allow the tubes to warm up to give him an idea of what the cable is going to sound like. And it's not that we were changing the way that it sounds, it's that the cable is the cable is the cable. What we did when an audiophile says I can hear something, what they're really trying to tell you is that I am starting to experience the change in thermal temperature. Okay, so if something gets really, really hot, you start to hear more. It's called recess mids, recess highs. So you would hear it more kind of like a when they're enunciating, or if they hit a cymbal, instead of the cymbal having like a sheen, it'll sound more like that type of thing. And all that means is that you took the transformers that are inside these appliances, and you've overheated them, and you're now getting anomalies because they're outside of their thermal temperature window. So when you put my cable on there, which gives them 50% more energy without pulling 50% energy, because it's getting rid of the residual artifact of the electrical line, what you wind up with is much lower temperature at the overall of the transformer, so they're less hot. And because they're less hot, you get that, and even the sheen coming off the cymbal sounds darker. You say, well, wait a minute, does it sound darker? No, it sounds more like different metals. If you know anything about percussion, then you know that pearl makes one sound, uses one type of metallurgy, and they have their own specific kind of sound. Pasty's got another one, the Chinese have a different one, and they all have different characters based on the size of the cymbal. And the whole idea of high resolution is that you can actually hear the different grades of metal. It's not just I can hear the cymbal. I want to be able to hear the different grades of the metal, also, as well as the different positions on the surface and how it interacts. I want to be able to tell the difference between if I'm using a rubber mallet or am I using a stick. I mean, all that type of stuff. Or I'm using a brush. Am I using a short brush? Am I using a long brush? All that type of stuff. Am I using a wooden snare drum, or am I using a metallic snare drum, or am I using plastic mylar heads versus paper heads versus all that type of stuff? And we generally describe not being able to hear these things as a variation of clipping, but it's mostly a variation of thermal temperature. So now when you get the thermal temperature just right, all these different characteristics of color now bloom out from the piece of electronic. And that was the whole point of waiting a half hour and then letting him hear it again. Because when I removed it and I put the other cord back on, I gave him the same half hour. And I said, see, you're hearing much more higher levels of thermal temperature on this product that cost me $5,500, cost me $2,500 for the DC biasing, and all the other tweaks that I put on it over the years that the company said I absolutely needed. So for $8,000, you were still hearing an elevated thermal temperature that was causing the transformers in this piece of electronics to come outside of their specification. Whereas mine, within 30 minutes, was complete in specification, and actually probably was a little bit lower because we heard more color in there. And the more color, that kind of means that you have more of a drag on the line, which there's nothing wrong with a drag on the line with transformers. That's how you keep them cool, you know? So, from that aspect. But at the same time, I'm trying to give you a description. Like I'll give you an example. Let's say that your husband, your spouse, you, whoever owns the stereo system, right? And you go and you lower the ringing noise or the digital RF coming off of the chips in the processor stage, right? Maybe you use an external amplifier. Do you use the same type of cord? Interesting. Interesting question. So a lot of times, I would say yes because I want to sell you a cord. And don't get me wrong, there are some microphonics that on the amplifier that the cable is able to go and filter out. But what is the main reason? I just answered this just 2 seconds ago. What is the main reason why you'd want to use a cord like this on the amplifier? Reason, you want to lower the thermal temperature of that big honking transformer that's on the inside of your amplifier. So the larger the amplifier, the larger the honking transformer, the better of an experience that you're going to have with it. One of the components that we were discussing, I know I'm boring the EMF folks. Is Dave and I were discussing the benchmark DAX, and the reason for it is that benchmark DAX they're half size components, and they use transformers that are about this big. Okay, and the problem is they're just not large enough in order to get a low frequency vibration to give it warmth, right? So they have to do it using other means in order to do that. But there are ways to excite the transformer in order to get warmth out of it. And as you excite it, and the lower you're able to lower that resonant frequency of it, the greater of the reduction of EMI and EMR that you can actually provide on it. I don't know why. I mean, it benchmarks a cost production. How do I build this stellar product for the least amount of cost? They're like every other electronic company. They're counting pennies. But again, understand the concept of what I'm trying to say. This as far as the EMF world is concerned about. If you were trying to get rid of radiation, if you were trying to reduce line noise, which you all are because you're plugging all these fucking filters in all over the place, you're trying to do it using differential mode filtering, even though differential mode filtering can only give you, in all honesty, about 27% of reduction. And then after a while, if you plug too many of them in, you actually cause a phase shift in your electrical line, which is what you're trying to avoid in the first fucking place. Because that was one of the things I always find funny about all these different products is that you plug something in the wall and you get phase shift. So your line, which here in North America is designed to be a low pass filter, meaning that I want low frequencies to pass through the line. That's how I get my ULF and my even harmonics on the line. And I'm going to slope off high frequency noise. So all high frequency noise above X amount of cut. Okay, cut is basically means at 1,000 hertz, I start to roll off 3, 6, 9, whatever. The idea is that that's how you keep a noise-free circuit. That's how you keep EMR on the circuit low. That's how you keep harmonic noise and RF. All these things that these meters are saying that they're going and doing, which is a cock and bull story. You're trying to get that. But you go and you buy into this concept. I plug this in, I plug this in, I plug this in, I plug this in, capacitor, 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 capacitor. And now you've done something else. You have changed the thermal temperature of the line. And you say, well, what's the problem with that? Well, again, remember, your line naturally wants to be a low pass filter. So every single time that you plug a capacitor in, you drop the low frequency down by 3 dBs. So eventually what happens is that if you have 3 or 4 of these in your home, remember the electrical line is one big gigantic field. It's not separate lines, even though you have individual breakers. They're all one gigantic field that are connected to each other. So it doesn't really matter if you plug it in on circuit A or circuit B or circuit C or circuit D. They all interact together by dropping the lower frequency down 3 dBs every time you plug one in. So now you've wound up with what is known as high pass filter. High pass filter looks like this, right? It's reduced by, let's say, by 12 and then by 1,000 hertz. it's flat. You say, well, what's really bad with that? Well, the whole idea is that these fucking meters that they're going to look and say, look, we plug it in, it's measuring at 2,000 hertz, which doesn't do anything with static electricity anyway. But in reality, where RF actually travels on the electrical line, instead of having it sloped where you have the inductance in place, where it squelches down the high frequency pitch noise, okay, you now have this open fucking highway allowing high frequency noise to travel freely throughout the house. And you have no inductance because you use differential mode to go and suppress the line noise. And because you're now allowing them to go and freely travel around the house, everything that you spent the money on, you're thinking that you're dropping the noise here, blah, 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 right? You did dick. You did nothing. All you did was create a high pass line circuitry. You're not, RF is travels at 100,000 hertz, 150,000 hertz, 250,000 hertz, 1 megahertz, 10 megahertz, 100 megahertz, 500 megahertz. That is where you find RFI. Where do you find EMI at? 250 megahertz, 300 megahertz, 750 megahertz, 1 gigahertz. These are the frequency ranges that you find electromagnetic interference at. You don't find anything in 2020 except for static. That's it. All you're listening to is the ionized field. And you say, well, why does plugging something like this in lower the noise? Okay, understand. You are just measuring 2,000 hertz. That is fucking static electricity. The same shit. You stick the balloon to the top of your head, and in February, and it stares there and goes, "Oh, kids, look like an idiot," right? That's what you're doing on the electrical line. You're not doing anything else. So the argument is that the only reason why these meters pick up the reduction is because the static field in electrical wiring is the ionization of the electrical field. And you are measuring the ionization dropping. Again, 3 dBs, 6 dBs, 9 dBs, 12 dBs. The reason why it's dropping is because your line that's supposed to be like this is doing this. And that is a bad fucking thing. You never ever want to turn your electrical field, your house, your electricity, your electrical field into a high pass filter. Never. Never fucking ever do you want to do that. Like before, we were talking about receivers and then speakers, and I said, well, speakers too, right? And that's because, and this is why they shield, the home theater speakers have to be shielded, because you're actually able to, not RF, but electromagnetic is able to be attracted, obviously, to the magnet around the basket inside the speaker driver. So you're trying to block that a lot of times, but the reality is that you don't really block it because you got to ground the plate in order to drain off the block. Okay, so it's basically your plate is reflecting, 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 reflecting to the point where it saturates. And then, like any other field, once it's fully saturated, it bursts, and then you start all over again. But the industry considers that to be kind of an acceptable allowance of electromagnetic, okay, because the burst is quick. And obviously, the more that you space the speaker, 5 feet, 6 feet, 10 feet away from the television set, the likelihood that you are attracting any electromagnetic is, but the way that is exactly what the EMF folks go and do. They grab their handheld meter and they start at the wall and they start stepping backwards and they measure how amplified is the electric field as well as the magnetic field. And when the magnetic field starts to cut off, okay, or just completely drops off, they kind of, they say, well, this is a safe range. Now, within that big, gigantic 6 to 9 feet from the wall, I have to go and figure out how to absorb that, redirect it, or whatnot. And that's what a quad wave and a tech ground, that's what they're really designed to do. And you should use the same exact thing. You take a handheld meter and you start spacing from the television set, and you will know where the magnetic field of your amplifier drops off, which is great because remember, the magnetic field of your amplifier is the radiation field, right? So you know the radiation field is coming this way, you know it's going that way, and you know it's going this way. And you want to make sure that your speakers are offset outside of this field. So don't think everybody's crazy. Get yourself a handheld where you see the magnetic drop off, go 2 feet, and that's where the speaker goes. You say, well, I don't want to, now my speakers are spaced 18 feet. Well, then you know to put something in between to absorb that so you can start moving them closer together. Because only when you do that will you realize the purity of the signal, right? Because the radiation is affecting the signal that you have, no matter how thick your fire hose speaker cables are, no matter how many things you have them elevating them off the floor to get rid of static electricity from jumping into the thing, um, which is really not what those things really do. They change the resonant value over the length of the wire instead of static, but you can hear it. But anyway, that's the whole kit and caboodle. So the concept is that by looking at something like the EVO power cable and lowering the thermal temperature going into the component, lowering the noise, that helps you eliminate what's being leaked back into the circuit. That helps us to operate with less stress. And if it's less stressed, then it has less overall leakage. And you may poo-poo the idea because it's an $825 power cord. But at the end of the day, think about all the money that you spend on all these other things that you plug in the wall, you slap on the desk, you put over there, when you could have just very easily. It's all about the right tool for the job. And yes, if you're addressing the room, then God damn it, yeah, put a quad wave in the room. Yes, put blockers around the room. But also, don't forget that you have a source that is in a constant dumping this into your room. So if you can reduce the source, you take the stress load off the room. That's the idea. So don't poo-poo it thinking, well, he's doing it for those other people. I am just a power guy. I just develop product. The product is to be used by everybody on the planet. You are the ones who lack the imagination of what it's going to do. I'm trying to give you some ideas of how you can use this stuff. Okay, I'm not saying that you put it on everything, but if you have those brick power supplies, they're notorious for noise, but they're also notorious for voltage instability. You look at plugging directly into the computer, right? Because it's, like I said, it's a full tower. Again, lower the thermal temperature of the unit itself. It does wonders. So there you go. There you have it. It's don't poo-poo things like this, because at the end of the day, this is about overall well-being. I mean, would you freak out if I told you that the power cord also pushes off negative ions? Not a lot of them, okay, but it has that filtering built in as well. You say, well, what does that do for you? Static. It helps, So if you have a 24/7, it helps you deal with static in the area of the electronic, because understand, like you look at the back of the PC, and there's ventilation for the power supply. Well, that's just dumping radiation and ionized fields into the room. So now you have a cord that has it built in right there at the IC, which is the power inlet for the computer, and it's putting out a small little tiny field of negative ions. So as the radiation, as that ionized field is coming off, guess what? It's squelching it. That's another way that this cord is actually lowering the in-room levels for you. So I don't, when I design things, I just take a look at the overall picture of things. What is going to give me what my signature requires, Good friend of mine. We were on the phone last week talking about his product line versus my product line, and we're kind of we're kind of designed to be used together, you know. And when you do that, from because he's an audio guy, when you do that, you get this really spectacular sound quality because his train of thinking of middle C is my train of thinking of middle C, and they just seem to go and complement one another. Would I use that in the EMF world? Not really. You know, raising second order harmonics, sometimes that can be a benefit to lowering radio frequency noise off of the cable box or the internet router. Raising second order harmonics would absolutely work. It would help in the receiver situation, the flat panel display situation. Um, Sometimes it helps in the computer. It really depends on the computer. If the cable is connected right to the computer, then it absolutely helps. It's a larger power supply. But if it's got one of these brick walls, the likelihood is not really. So, but again, these concepts, there's nothing wrong with them. It's a great way to reduce the noise that is both electrically and airborne. The whole idea at the end of the day is no matter what you plug this stuff into, you're really, I mean, you live within the room. You are trying to take the stress off of the room. And if we can do it this way, then it all helps out. I have an individual who is, she's learning the ropes of our business. And, once a week, she asks me a series of questions on how it pertains to this. And sometimes she understands it, and sometimes she got it wrong in how I described it. But at the end of the day, it's measure. In this business, measure less because the measurements are um, not as accurate as you think. They're just more ballpark, and a lot of times that ballpark will change hour by hour. So it's take it with a grain of salt. But use tools that you absolutely know are going to reduce the noise structure, that you plug in and you walk into the room and you just generally feel better. It's like I was talking to somebody the other day about the insert, and you say, well, the inserts now are two-sided. So one side is high frequency, the other side is magnetics. I'm trying to take the guesswork out for the client. We used to sell multiple different models, and the clients were so confused they didn't know what to buy. They just thought the most expensive. You say, well, are you this in particular? I don't know. And this now gives you a gauge. It lets you know exactly what you're bothered by. People that have for years have been telling me, Alan, it's high frequency, it's high frequency. They buy the new EVO insert, they flip it over to the magnetic side, and they say, I feel fantastic. What did the other side do for you? Not much. Guess what? You're not sensitive to high frequencies. What? Yeah. The black side, high frequency. The silver side, magnetic. So, I mean, I even had one woman argue with me. This is middle of last week. She's arguing with me on the phone. She said, "My naturalist, my naturopath, is telling me that I am high frequency. I am Wi-Fi sensitive." I said, "Ma'am, you are not. If you were telling me that the silver side of the insert and you feel fantastic, you are not. Now, that's not to say that you are not mired by the electromagnetic field or the radiation that comes off of the Wi Fi character. Remember, it's frequency, it's electricity, and it's a radiation byproduct of the electricity. That does, okay? But the frequency itself, if the black side didn't help you in any way, shape, or form, then you are not frequency sensitive. You're only sensitive to the magnetic field, okay, from the electrical and the radiation. So now you know moving forward how to go and filter your home. You don't want to you don't want to plug anything into the wall. I mean, you want to plug a blocker, that's great. You don't want to plug an EVO1 or something like that, or an RF or anything types into your home. That's why, because you're not frequency sensitive. You're only electromagnetic and radiation sensitive. So you want blockers, you want quad waves, you want tech grounds, you want EVO power cords. These are the things that lower in your environment. You want a pocket ground. You want to wear the inserts with the silver side up. These are the things that you personally need. Remember, your personal space, your personal need. Everybody is different. You may be affected by magnetics, and your husband turns around and says, "No, no, that's not working for me. It's not working for me." Flip the inserts over to the black side, and 10 minutes later, he goes, "Oh, I feel pretty good." And then 45 minutes, he says, I can see that tree out in the yard through the window better. And it's like high definition. Whoa! You now know that your husband is frequency sensitive. Do you have to change the filtering? No, he can still work with a quad wave. He can still work with a pocket ground. He can still work with a tech ground. He can still work with a blocker. He just wears his insert the other way. We are trying desperately to figure out a system that works for everybody in the household. Everybody in the household has something, if they recognize it or not. You may say, you must have it, you must have it, and you just keep throwing magnetics at them. They're going to say, Mom, I don't know what the fuck you're talking about. I don't feel nothing. You nuts, Mom? Mom, you need a hat. Hang on. Karen, give me the tinfoil. Then you flip the inserts over, and 10 minutes later, she goes, oh, wow, Mom, I do feel different. Everybody in the house has some type of problem. You just may be a different frequency level. When I first started this, I used to tell people that electromagnetic sensitivity is really an allergy, and that's true. Okay, your body is reacting differently based on the frequency range that you are injecting the vibrational pattern for, and but not everybody is the same way. This is why doctors are having a hell of a time really pinpointing it. And you should see the shit I got to go through when I have to talk to doctors. Say, doc, you're looking at this the wrong way. You got to look at it like this. And then, when I provide them the tools like the pocket ground, and I provide them the tools like the insert, and they flip the insert, and they do this, and they take a look at how their client base interacts, they go, holy shit, he's right. There's low, mid, and high frequency changes. And just by swapping this device for that device or flipping this over for that, we can now actually treat it. Before, like I said, we had too many models of things. It was too much confusion. And no matter how many times I explained it to somebody, they always thought that more expensive was better. It's the same fucking problem I got with the audio files, right? They'll also say to me, well, that one costs more. So I was a dickhead, right? I was a dick. I came out with these 4 different filters, right? And I priced them all at the same price. Each one does something different, but I priced them all at the same fucking price. And then I confused the shit out of them. They didn't know what the fuck. They all work together. But which one's better? They're not better. They're all the same. They just do something different. They're designed to work together. Some got the concept. 99% of them did not. And it was the same thing with EMFs. We came out with we had the traditional insert, we had the prescription, we had the harmony, and we had, and it just confused the shit out of everybody. And it was easier just putting everything into one, letting them give me 15 minutes. 15 minutes on one side, 15 minutes on the other side. Which one feels better? Do I got to be standing? No, you can be sitting down. Just put your fucking bare feet on them. All right? Once you figure it out, grab your favorite shoe, pull out the rubber lining on the inside, slip the insert in, put the rubber lining back on top, and go out and have happy thoughts for the rest of your life. At least you know what you are bothered by. I just can't tell you how many people would sit there and argue with me over and over again. I'm this. How the fuck do you know? Well, my naturopath. What fucking makes you think they know their ass from a fucking hole in the ground? And they get all freaked out. Who the fuck knows if they don't know their ass from it? I have no idea. I talked to so many of those quackanoids. I can't even tell you. I had one time lost his fucking medical practice, lost his license. You know, the state and federal government stripped it from him. Why? Because he was doing immune things to little children. So now he's walking around all these different, autistic events, and he's making sure that he's picking these children that are, either have almost nothing wrong with them, but mom thinks there's something wrong with the kid. I mean, I would take those kids off to the side and just start shooting shit with them, and you'd find out that mom needed the joint more than the kid did. The kid was fine. Mom, on the other hand, she was young. She'll know what it's like to be a mom. She's part of It Takes a Village, and you know what I mean. One of those types of things, and she needed the joint more than the fucking kid did. And then the other ones that they would go and really really sucker the parents in were nonverbals. And you know, yes, I understand a nonverbal child is frustrated and there are violent outbursts, but there are ways to deal with the violent outbursts. Making the child stoned is not for the rest of their life. What did you accomplish? Nothing. On the other hand, you plug a blocker in, you create a small safe space of zero free, and you let them gravitate over to it all by themselves. Let them discover it all by themselves. And you will start to notice, hey, guess what? They're hanging out there all day long, or when they get frustrated, they gravitate over by because they already know. Don't think because your child's nonverbal that they don't comprehend what makes them feel better and don't. They just don't know how to communicate it to you. That's all. Let them tell you. And when they gravitate over to the blocker, fantastic. I have never walked into an autistic household where they couldn't benefit from the blocker. Now, a lot of families don't want to spend $1,000 and put 15 in the house, okay? But so they'll buy one or they'll buy two. Nothing I can do about that. My job is to walk into a home and say, what do we need to do? Oh, I understand. We're going to make a zero free house. Well, this is how it's done. Some people have that kind of money to do it. Some people don't, you know. So now I look at priorities. I don't care what the mother and father's priority is. I sit down and I talk to the child. If the child can talk to me and I can kind of get an understanding of where this child is on the spectrum, because don't get me wrong, I'm not a bullshit artist. I will sit there and tell you there's nothing fucking wrong with your kid. Oh no, yeah, you're right. The guidance counselor who's not qualified, the shrink who's really not fucking qualified. Well, you can tell the shrink is not qualified because he's a shrink. You need a neurologist to tell you. Autism is a problem with the brain. There's a synapses that didn't grow. It broke or it didn't grow. It's not being connected to the appropriate spot. And then on top of it, the electrical signal from the synapses, the brain doesn't shut it off. So it's firing and it's just hitting the wrong spot. And now you have an interaction. That interaction could be a host of 1,000 different fucking things. Try the blocker. I guarantee you the kid will gravitate to it. Guaranteed. You know, I used to get these families with the kids had ADHD, and it's same solution. And he said, "Oh, you got to answer the task." And I said, "Well, from a dietary standpoint, they don't eat candy. Okay, what do they eat?" I ask this because I have a unique situation. I'm not diabetic, okay, but I go through diabetic um, symptoms. My body produces way too much insulin for whatever fucking reason. So if I take too much carbohydrate, which converts over to the sugar, or I natural sugar, great. It doesn't have to be candy bars and sodas. It could be grapes or whatever. or any type of vegetable that has higher levels of sugar or starch, my insulin will spike. And when it spikes, guess what? Just like any other diabetic, I will eventually crash. Except I crash with a how do I explain this? I will have a seizure from the crash versus just being physically drained. And a lot of people say, why don't you take seizure medication? Because I have, and it doesn't stop it. Again, once they found out it was my insulin that was actually causing this roller coaster ride, the seizure medication was yanked. Doesn't do you any good. I mean, I'm not being affected by strobe lights, which is the seizure medication works on parts of your brain, not on this other stuff. So it doesn't, doesn't work out that way. Um, but parents that were on the ADHD medication, um, I used to ask them. I said, "What's the diet?" Well, they don't do this. What do they do? Well, they have fresh snacks when they come home. What do they have? Well, we have carrot sticks, sugar. We have grapes, sugar. Um, they get homemade this, they get homemade that, sugar, sugar. Okay, so little Johnny is getting natural forms of sugar that his body is burning off by running around. See, the old days, mom and dad used to throw us out in the street, right? Go play, go up to the park and go play. Nowadays, everybody needs a play date, so everybody is stuck at home, and nobody understands that kids got to burn the fucking energy up, so they must have ADHD. Really, you know. Well, we enroll them in sports. Okay, they're enrolled in sports. Let them go play. You know what I mean? Well, we can't do that. There's things going on. There's this, there's that, there's this, there's that, and this. They live in this bubble of fear. And that's why everybody needs a trophy, but I digress with that shit. But anyway, I used to say to them, there are ways to lower most of what they would describe to me, I would classify as ants and pants, right? And I said, there are ways to deal with that. We can put a quad wave in a room. And one of the things a quad wave does is that if it's in close proximity to you, you get this really warm and overwhelming feeling that goes through your body. It is a calming experience like you've never got before. And really, what it's doing is that it's lowering inflammation in your body, which is raising oxygen. You're getting euphoric from it. So we used to do this thing at the breaker panel where we would put in certain materials on the inside of panel and so forth, and plug certain things in the wall that would give you a house-wide negative charge. And those types of houses, when we were still doing that stuff, I would just say to parents, let's do this, try it out, and tell me how you are after 30 days. And they would always say to me, well, the first couple of days, and they always make sure to let me know within the first 2 hours that nothing's happening. What do you like 3 days? And I would say, what's it like 3 days later? The very next day, nothing's happening. Nothing's happening. Third day, nothing's happening. The fourth day, they would say to me, they napped. Oh, how do you feel? Oh, the house is very relaxing. That's right. Because ants and pants, yeah, sugar, 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 sugar. But at the same time, there is a chemical response, which is the overacting, which is what the ADHD medication is trying to suppress. And all you have to do is that sometimes, and we notice this more today than we did 30 years ago. And it's not because we didn't recognize it 30 years ago, it just didn't exist. Today we have the entire environment we live in is wireless. The question is how many overlapping wireless signals do you have in your house? So as you start to ground them out with these low frequency fields that we're using in the quad wave and so forth, as you start to ground them out, you start to cancel out, or at the very least, reduce these overlapping fields. And you notice it because 3 days into it, you feel pretty tired in the middle of the afternoon. Now, the EMF has always told you, well, bullshit, you should have more energy and you know what the fuck to do with. That's what that means when you get rid of the EMFs. That's bullshit. Your body has to go through a relaxed state. Imagine this, right? Here you are all day long. That's an electrical signal, okay? That's 2.4 gigahertz, one channel, all day long. Now, imagine having 5 or 6 of them smacking you in the head, smacking you here, smacking you there, all day long, 24 hours a day. Do you think that you would be tired or you would be agitated by that? Good. Once you come to the same conclusion as I had, that you would become agitated by that, how do you think you go and sell that? Remember, they want to give you a plug-in device that creates your electrical load like this and switches it to that. Okay? So now you plug these things in, you get oodles of RF. I have never met someone who's plugged that kind of stuff in who's never said to me, "Hey, Alan, I feel worse now that I've done that than I did before I did it." Right. Okay. Once again, you're allowing RF to freely flow through. Not that it's jumping from the electrical wiring, even though you have more abundance of it on the electrical wiring now. The odd harmonics are not leaping off and bothering you. But you see, your electrical wiring, which is designed to do this, okay, because you have this big, huge inductive field, okay, also helps to reduce and induce fields that are passing through the field from outside and through the walls. So that's how you're able to block from this room to that room or from outside to inside. Have you ever tried to use Wi-Fi outside your home if your router's inside the home? And your husband puts it in the basement or he puts it in the attic space, and yet you still can't get any fucking signal, 30 feet from the house. Why is that? That's because Wi-Fi, that's because frequency doesn't travel through surfaces. It can't vibrate through a brick. It has to go around the brick. It has to find an opening. So it bounces all over things until it goes and finds a way out. No different than you. It can't pass through you. It can just bounce off of you. Every time it bounces off of you, it creates inflammation. And that inflammation is what, bothers the body because you get a chemical reaction to that inflammation. And because of that chemical reaction inside your body, it can slow down your immune system. It can give you headaches. It can make you agitated. It can cause sleeplessness. But if you put your body in this nice, warm, and inviting induced field, you physically ground all of this off, or at the very least, take this and slow it down. You say, well, what does that do? It's still smacking me. No. The longer that you are in this wonderful induced field, slows, vanishes. No different than shielding the power cord we were describing earlier over the length. Okay? If you can squash it, reduce every single centimeter over the length, then by the time it comes out of the wire, into whatever you're plugged into, it's noise free. The longer that you stay inside that field the quad wave is setting up, and to the point where, boom, and you say, well, why is that? Because as you're in this enriched, induced environment, your body is producing more and more oxygen levels. And yes, in order to get there, you have to go through, because you have to bring your nervous system down. Your nervous system, even though it's a theta wave design, it's got all these different resistance peaks from every single time you got hit with these things. Okay? And don't think you just get hit, once in a blue moon. Oh, I got a ripple. Well, no. You're getting hit 24 hours a day. Okay, 2,400,000 times per channel of wireless. Your Wi-Fi, your neighbor's Wi-Fi, Verizon, AT&T, Sprint, Comcast Cable, Cox Cable, whoever the fuck is doing your area. Every single overlapping is smacking your body anywhere from 2,400,000 to 5 million times. Okay? So you are constantly bombarded by it. Whole idea is to squash it, to absorb it, to eventually rid it, to eventually convert your body into an oxygen machine. Because nice thing about oxygen, when it mixes with iron in the hemoglobin, is that it becomes a repellent. And now all these electromagnetic signals that are attracted to you in the first place because you're 98% fucking water are now repelled to by you. We used to, when I first came out, we used to say it was the force field that it went create. I couldn't figure out any other way to describe what was happening and have the other individual not think I was nuts. Try it, this and that. Oh yes, it's doing all these different things. No, it's not. It's doing one fucking thing. One fucking thing is it's forcing your body to produce more oxygen. You don't got to take my word for it. You can measure your blood oxygen ratio. You will see it with use and without use. And when you do that, you repel. When your house, remember, air in your house is not oxygen. It's mostly hydrogen, right? Okay. So what is the ratio? 20/80? It's either 70/30 or 20/80. I forget. But let's say it's 20/80. So you're 80% hydrogen, you're 20% oxygen in the house. Okay. That's one of the reasons why you have to go and buy, X amount of filterings, okay, in the room, and you have to zone the house and do it properly and so forth, because you only have a little bit of oxygen to really play with inside the house. Now, when you're able to move that low frequency and the oxygen together, poof, you get all this different negative ionic discharge, right? And then I always say to you, well, the ionic discharge, it works with the water molecule, which is made up of hydrogen and oxygen, right? And based on how hot I make the water molecule, how cold or hot I change the thermal temperature of the water molecule back to thermal temperature. Everything is based on thermal temperature. Depending on how hot or cold, I can dictate, am I creating more oxygen or am I creating more hydrogen? And you don't want to create more hydrogen. That's why I always say keep your temperature in your home roughly about between 68 and 70, if you can. Not everybody can do that. If you can, try to dehumidify your home during the summer months and try to humidify your home during the winter months. You really want to keep the moisture level, okay? Maximize the water molecule about 55% year round, if you can do it. Again, I can't do it in the wintertime because I got forced air. So, it's like a fucking desert in here come February. But if you're able to do it, this is one of the reasons why I get more customers in the winter time than I do in the summertime. It's got nothing to do with, well, they're home in the winter and they're on vacation and stuff. No, it's all on the water molecule, because you can tell by what part of the country they live in to the questions they ask and what I recommend them to buy. You might think not, but yes, I recommend different things for the coasts than I do for inland, depending on what time of year and what they're describing to me. So, but again, I don't know. I think, I don't know. Are we good? I've rambled for an hour and 19 minutes. Are we good? I'm trying to explain the right tool for the right job, and hopefully, at the end of the day, like I said, it's really all about how we control the thermal temperature of whatever it is. Just don't think thermal temperature is electricity only. It's not. It's atmospheric as well. Okay, it's within your own body as well. So you are trying to get all these different things to unify, to gel. And that's what all these tools are about. So moving forward, folks, please like and subscribe and share. I hopefully you learned something from this. I wasn't too sarcastic in the process of doing all of this, and please stay safe. Have a happy, and we'll talk again next week. Thank you very much for watching. Like, subscribe, and share.